Okay, here we go. Do me a favor. The triangle with vertices negative 4, 4, 3, 3, and negative 3, 1. Is it an isosceles triangle? How do we determine that? Think about it. Look at it. So I want to go ahead and graph out my points. Back 4, up 4 will give me A. Over 3, up 3 will give me B. Back 3, up 1, C. I'm going to go ahead and connect them. Okay. Let's check if it's an isosceles. The way we want to be able to do it is find the lengths of the sides. So I'm going to look at the length of AB. And using my triangle method or Pythagorean theorem method, this is going over 7 down 1. So 7 squared plus 1 squared. My answer is going to be the square root of 49 and 1 is 50. Do you need to reduce down? No. You can leave it like this. It's actually preferred to leave it like this. Okay. The next one, we're going to go BC. B is 6 squared plus 2 squared. 6 squared is 36. 2 squared is 4. 36 and 4 is 40. Our last one is our AC. Creating our triangle out of this, we're going to get 1 plus 3 squared. It's going to give us 1 and 9, which is square root of 10. Now, we can stop there. Is it an isosceles? Yes or no? Why is it not isosceles? So in this case, no. It's scalene. Since no 3 congruent sides. If we want to take this up another notch, though, we can actually determine whether it's a right scalene. Can we determine that? Oh, 2. Thank you. If we want to take it up a notch, we can find the slope. Our slope will be 1 over 7, so AB be 1 over negative 1 over 7, sorry. Our BC will be 1 over 3, or 2 over 6 if you guys didn't reduce. And our last one, AC, will be negative 3 over 1. What we conclude from this are these are so it's a scalene right triangle. In this case, it's going to look like one of our sorry. I yawn, you yawn. You yawn. That's how you get them. Who? Oh, you? Or were you kipping? Okay. Because camping is awesome. You guys like straight up camping, like in tents and sleeping bags, or were you in a RV? You guys go fishing? No, just camp. It's typical. It's typical. Where is Carpenter? Where is it? San Diego? By the beach, yeah. Why? Is it San Diego? San Diego County? Where is it at? Was it further north? Typical kids. Yeah. Okay. Here's the one thing that we're gonna write out.
Whoa.
Not fancy.
Why'd you write on the drawing board?
I don't need to step it up.
You always have like inspiration. You stopped after like this semester. Yeah, like you erased it. And when I went to there's like math stuff, and I was like, sad. I know. I feel like my sixth grade. I feel like that's. What was my sixth grade? I had changed sixth. Yeah, I feel like it was my sixth grade.
So you wanted to get on my classroom because you hated it?
I didn't want to do that anymore. I wanted to be in a school. I wanted to get up to be. I never considered but like the movies you can't skip it, but you still have a oh no, you can't. She finds out if you just
Scalene, this is what I'm not going to provide you tomorrow, so I would like for you guys to copy this down. This is Scalene Triangles. Whenever I'm giving you something like this, you want to be able to show that, first of all, it has 3 different sides. By definition, if it has 3 different sides and it's a triangle, it's scalene. The second one we're going to look at is isosceles. We just kind of did this one almost. Isosceles triangle is a triangle with two sides congruent. If you have a triangle with 2 sides congruent, definitely isosceles. Our last case and our last scenario here. Ooh, it's like a nice salmon color. We have an equilateral triangle. Equilateral triangle means that we have three sides congruent. Now, the crazy thing about this is these all show distance. The last one we can talk about is it has the right angle property. Scalene isosceles equilateral talk about the sides, so you got to find the distance formula using them. But a right triangle talks about their slopes. This will not be provided you for the test. So you guys got to remember what these properties are for the scalene. Just like it was today, right? It can give you prove or disprove it it's scalene, prove or disprove it's isosceles, prove or disprove it's equilateral. So you have the opportunity to show me if all sides are equal, it's an equilateral. If you have two sides, isosceles, one side, nothing. Scalene. Okay. Let's keep going. Let's try this one. You guys have these if you guys want me to write down the points. J is at -2, 3. K is at 4, 1. L is at -1, 0. And M is at -4, 1. Explain why or why not is jklm a trapezoid? Do we know the definition of a trapezoid? We should know it, right? What makes a trapezoid a trapezoid? Only one pair of parallel sides. So we just got to be able to show parallel sides to this. Unlike the triangles where we had to show distance, with a parallelogram or a trapezoid or a quadrilateral, just depends on whether they have parallel sides. Okay. So now we're going to be able to just look at slope. So I'll give you guys time to copy that down and graph your points. First pair here, we're looking at MJ. MJ is going to be a rise over run, or 2 over 2, which is just 1 over 1, or just 1. JK -2 over 6. That can be reduced down to -1 over 3. Are those two parallel perpendicular? No. They're not opposite, reflipped, and they're not the same. So they're definitely not parallel. So we got to continue on this journey of math. LK is going up 1 how far over? The left by 5. So we have 3 of the sides not parallel or perpendicular. Let's check our last one. So ML is going to be down 1 over 3, -1/3. Okay. Now, to make it a parallelogram or to make it a trapezoid, what do we need? Only one pair. Do we have one pair the same?
Yes.
Specifically, what 2 pairs? So this is what I would want to see. I want to see JK is parallel to ML. If that holds, trapezoid. So I would say, yes, it is. Why or why not? JK ML is one pair, is the only, how about that? Is the only pair parallel. Pretty Polly predicts parallel pairs. So Polly predicted the parallel pairs of a parallel polygon. Oh, fancy. Okay. So be quiet. So be quiet. I got you. Done. Se habla español.
Oh, yeah, she wants you. She hates us. She hates us. Yep. Oh, she talks about us.
Said I don't like my third period either. No, I don't like them all, but they're just talking.
I just guess
No.
that she doesn't talk about much about yeah, she
Just compares us.
Okay.
She's like second period.
Here's our quad proof. So this is the other part that I want to give you guys that you guys do not have. If you have these two things that we written down, the one that was green before with the you guys have the other pair, we're going to be good here. The quadrilateral proofs is kind of a big thing. This encompasses everything on the front page. This is the majority of your points. So it's going to ask you to prove whether they're the triangle. It's going to ask you to prove using slopes. The last one is proving everything. So you got to be able to tell me everything it has, just like it does on the test. The overall theme of this that we talked about first of all, and I'll kind of erase this. We'll do a fancy proof by induction. So quadrilaterals. So quadrilaterals, and I got to write small because I got to fit a ton of things on here. Okay, it's the same thing that I'm going to give you guys. I'm going to give you guys another thing to look off of tomorrow, but it's coming from the same thing. The quadrilateral, what we're kind of going to define it as, is just a we want to be able to put what it means to be just a quadrilateral. And let me kind of try to draw these in different colors. So by definition of a quadrilateral, it's just a four different sides. And then the other thing would be no parallel or just four different sides, no parallel or perpendicular. Four-sided figure. There's nothing else we can come up with. Okay. Stemming from a quadrilateral, we have several different things that we can actually look up, and we got to be able to define them depending on how we. So let me box this up. Let me do this. Box it up. Box. And our first different type of thing that I could still give you, we really haven't done a proof like this, but we can still do it, is a kite. You kind of block this off. We have a kite. Our kite has the properties as the following. We have two pairs congruent, no parallel, and no perp. So we're going to have two pairs that are congruent, no parallel sides, no perpendiculars. Okay, but we can still have two congruent parts of them. It doesn't mean that they're not anything special. Okay. Here's our next one. I'll box up. I'll squiggly it. So we have a kite out of that one. The next one we got to look at is the following. We got to go this next one down below and the next one on the side of it. The side one is going to be a I'll be your trapezoid. Whatever. Trapezoid, we specifically have one pair parallel. Ooh, ah. From a trapezoid, we can actually have one more property, which is, can it be graphed? Oh, look at that. It's going to look beautiful, that. Isosceles trapezoid, meaning we have two congruent sides, and I know this is kind of tiny. We have one pair parallel, one pair congruent. Well, it's kind of up there, but my apologies. I got to finish up the rest down below. Yeah, they're fun, right? From this, we can come up and get a parallelogram. Parallelogram has a special property in which we get two pairs parallel. Come on, man. Was it parkour? What? I know. Can't do nothing to make you guys happy. In our class, yeah. Here we go. So, from a parallelogram, I'm going to do a little fancy bubbles. So from there, we're going to have one type of thing. The first one being a rhombus. And a rhombus looks like we have all four sides. So four sides congruent, two pairs parallel, no perpendicular. So not perpendicular on any of the sides. Right, Matt? We're copying these down. Other Matt. Look, Chugo's playing with the pen.
Yep.
With the light.
Sounds about right.
Exactly. So what'd you say? A rhombus. From the rhombus, we can actually get from the parallelogram, a rectangle. From a rectangle, we get four perpendicular angles. Two pairs congruent. And then from a rectangle and a rhombus, we get our final fancy one of a square. With the square, we get all sides congruent with right angles. So the way we're going to write that is four perpendicular angles, four congruent sides. And if you can get that, then you're free falling. We're going to look at this, but you have to start practicing these types. Looking over the team test, it is a straightforward test. I can't be any more real than that. It ain't much more real than what you get in front of you. So bring up your grades. The cutoff day for the first test is going to be October 1st. After that, test number 1 cannot be remade. So if you're planning on doing it, start making the arrangements to complete it and get it done.
Wait, what?
Get it done.
Wrong date. Wrong date.